So we will move to our final presenter of the day, Dr. Roberto Sussman. So Dr. Sussman is a senior researcher and lecturer at the Institute of Nuclear Sciences at the National Autonomous University of Mexico. He's also the director of the nonprofit association Pro Vapeo Mexico that advocates for the legalization and appropriate regulation of non-combustible nicotine products in Mexico.
I would like to thank the organizers of the Global Forum on Nicotine for giving me the opportunity to present the video Environmental Vape Aerosol. Is it harmful to bystanders? Well, yes, according to the WHO in their own texts. The aerosols generated by ants typically raise the concentration of particulate matter in indoor environments and contain nicotine and other potentially toxic substances. Ants emissions, therefore, pose potential risks to both users and non-users. This is of concern as human exposure to particulate matter, including fine and ultrafine particles which may penetrate the alveoli, has been shown to be associated with increased risk of heart and lung disorders. And not only the WHO, most regulatory agencies and publicly funded studies conclude that secondhand vaping impairs indoor air quality and agree with the danger from fine and ultrafine particles that deeply penetrate the lungs. Is this assessment supported by scientific evidence? Let's see. Assessments on environmental vaping aerosol are based on two types of studies: fully controlled chamber studies and minimally controlled atmospheres. In controlled experiments, we have volunteer vapors that are asked to vape in chambers, closed rooms, offices, automobiles. They often follow predetermined vaping protocols, and of course, they vape in the direction where the instruments are located. Atmospheres are much more realistic than chambers. For example, in the same location, in day one, vapors vape long times ad libitum without restrictions and they generate a vaping atmosphere. On day two, indoor environment is completely vacated, cleared, and ventilated, and in day three, vapors are present but they do not vape, and so you generate a controlled atmosphere without vaping. Also, another design is in different locations. For example, in home one, vapors vape ad libitum and generate a vaping atmosphere. In home two, smokers do the same thing, generate a smoking atmosphere, and there is a controlled atmosphere where nobody vapes or smokes. We know now, and it is widely accepted, even reluctantly, that environmental vape is far less toxic than environmental tobacco smoke, but more and more spaces are now smoke-free. Therefore, we need to examine how does vaping atmospheres compare with smoke-free indoor environments. For this purpose, we need to examine and analyze the physical and chemical properties of the particles. It is not enough just to detect them, count them, measure them. We need to understand them. Unfortunately, most studies, either chamber or atmosphere, detect and measure particle numbers, densities, and diameters, ignoring their physical and chemical properties. This shortcoming also explains the misleading assessments by the WHO and by most publicly funded studies. However, now some studies do this task, like this publicly funded study in Spain examined vaping and smoke-free non-vaping atmospheres and analyzed the chemical composition of its particulates and its gas phase. This is the study. The first result that emerges is that vaping increases the density of particles. Here we have the data, and as you can see, both PM10 and PM2.5 increased, in fact, more than doubled between the non-vaping and vaping session. Now, this can be concerning. However, notice that many indoor non-smoking places also violate these standards. Nevertheless, these standards are important. We have to bear them in consideration. However, which particles are we talking about? The WHO and most public health agencies ignore the physical and chemical properties of the particles. They hint, without proof, that exhaled vaping particulates are somehow equivalent to air pollution PM particulates. Is this claim supported by experimental evidence? Because if it is supported by experimental evidence, then this is seriously concerning. This study found the chemical composition of the vaping particles. These are the list of compounds that form the particles, and among these compounds, we can identify two which form almost the totality of the mass of the particles. These are inherent to vaping, glycerin and nicotine. This means that without vaping, these compounds would be found in really negligible quantities, but here they dominate the content, and they are inherent to vaping. What about the other ones? The other compounds are common with indoor air pollution PM, and they appear in negligible quantities, right? And some of them, like pyrene and benzoapyrene, are carcinogens. And now you can see that both of them increased between the non-vaping and vaping session. However, remember we're talking about nanograms per cubic meter. 1 nanogram is 1,000 million parts of a gram. Therefore, even if there was an increase, these compounds are still negligible in the vaping session, right? Now, this study and other well-designed studies by industry or publicly funded that have examined the chemical nature of the particles show that it is indeed true that particle numbers and densities increase during vaping. However, this is due almost by 100%, it is due by the addition of glycerin and nicotine, which are brought by vaping. But these are not toxic in the environmental delivery doses. Remember, this is not inhaled aerosol. Toxic compounds of air pollution are also detected when vaping, but practically at same levels detected in smoke-free indoor environments without vaping. Therefore, the assessment of the WHO, of the WHO, and the most publicly funded studies is questionable. Let's look at another group of compounds, volatile organic compounds. They are also found, they are in the gas, and also they increase in the vaping session. Not so much benzene and naphthalene, I put arrows because the WHO identifies these compounds as major indoor pollutants. But notice that only formaldehyde increase, but even if it increase between 7.4 and 14 micrograms per cubic meter, formaldehyde is still below the WHO safety limit, right? So let's see these comparative references. Formaldehyde reached 14 micrograms per cubic meter, but let's compare it with measured values in non-smoking indoor spaces. We see that this value is perfectly compatible with these ranges of values. In fact, some of these values are far higher than the one produced by the vaping atmosphere. And the same thing with naphthalene, the same thing with benzene, and the same thing with toluene. Therefore, we reach this conclusion. Bystanders exposed to exhaled vape aerosols inhale toxic pollutants in doses comparable or even less than those found in non-smoking and non-vaping indoor spaces. Therefore, there is no impairment of indoor air quality that is brought specifically by vaping. Final message: vaping in public indoor spaces must be regulated, but there is no scientific justification for a blanket prohibition as with environmental tobacco smoke. Thanks for watching. Yeah. I just would like to add, somehow complementing my other intervention, that there is a lot of politicized literature on environmental vapor. However, even as much as they try to find some devils or bad creatures or whatever, it is so hard to find it that they end up with the issue of misrepresentation of the particles. Because with particles, PM or etc., and the conception that the common people have of particles is that little stones. A particle is like a little stone diminished to tiny proportions, and the image that you have is that lots of little tiny stones are going to bang into your alveoli and so on. And this is the way it is. But as I said, I did not comment any further. But the particles are well known. We know what they are. They are volatile. They are liquid, and it's almost completely composed of the same materials as the gas. Well, there are some elements are in the gas, some elements are in the particles, but it is not amongst them, the particles. So that's what I wanted to comment.
Roberto, when you look at the literature, did you look at, I think we did some of these studies, or at least our scientists are telling me, you look at the impact of lighting a candle, you go to a kitchen, and so it's a little bit like, I'm thinking that if the justification for an indoor vaping ban is health harm, maybe cooking might be especially frying, for example, French fries, right? Or lighting a candle, maybe as a comparison to explain the difference, maybe that would be a good reference point with some real world situations where similar processes occur, and what is their contribution to the indoor air quality versus relative to vaping, and then maybe the context would be a little bit different.
Yes, no, you're absolutely right. And but so far, there are some industry studies that have done that. Both industries, they have done this comparison. Also, there are several studies of public health that were not targeting vaping. They were targeting pollution and so on, and they also make a comparison with vaping, and you can see that it's the main point that highlights the relative safety of environmental aerosol of e-cigarettes is intermittence, right? Like, for example, air pollution is there, it's here. You cannot switch air pollution. It's there all the time. You can probably control it, mitigate it, put ventilation or whatever, but it's there. Now, when you vape, and if you are in the personal space, vape-free place, so you're going to be exposed maybe 20 times, 50 times more than the normal air pollution. But first, nobody vapes in the face of others, right? And second, the release of aerosol is very intermittent. It's just less than a few seconds. And because of the chemistry of the aerosol that is so highly volatile, it evaporates. So the exposure times are very small. This does not happen with smoking, because you can say smoking is also intermittent. You are not smoking 24 hours, you puff, etc. But the chemistry of tobacco smoke is completely different. It's mostly non-volatile or semi-volatile, so the particles that can be liquid or solid, they stay. That's why your hair, your clothes, or the environment after smoking, but this doesn't happen here. So intermittency, lack of toxicity, volatility, these are all things. So, and when you compare them with other aerosols, of course, that when you're cooking, you're going to be 1 hour cooking. But cooking aerosols, they generate what is so-called the secondary aerosol. They generate other aerosols because there are photochemical reactions, and they react with ingredients of indoor pollution. This doesn't happen here. And also candles, anything. These carpets, see, it's, I can say, if I say that it's innocuous, I'm going to be crucified. So I'm not going to say it's innocuous, but I can say that it is very close to being an extremely weak pollutant, and that there is absolutely no reason other than commodity or than being polite that you tell me, I don't want to smell your vanilla thing. So this has to be respected. That's why I say it has to be regulated. It is a little bit, I make the analogy with sounds. Like I enjoy a loud Beethoven symphony, but I have to be told that I cannot put this in a library. Or I cannot go to public bus with with a big. But people who like to listen music, whether it's Beethoven or hard metal, should have indoor comfortable spaces where they can do it. And I think this is the approach that has to be done with environmental vapor.
Thank you. Any questions from the audience?
First, thank you, Roberto, for the explanation. And I had to say when I began vaping, but when I realized that the exposure was lower than the variation of the same compounds in different rooms, where it can be addressed, in fact, because there are homes that are 10 times that exposure, and they can be identified typically with air replacement regulations, with a number of people in a flat and things like that. It's far more prevalent than dangerous. And do you know of studies studying the same compounds in other situations? For example, we had a discussion in France, everywhere, about air renewal in public places in residence. What would be the impact of more air renewal regulation on the same compound, the same exposure to all the population? If we say, for example, I think of public places, but in libraries or bars or things like that, doubling, tripling the exposure would have considerably reduced COVID transmission and would have also reduced pollution for all the people in all the situations.
So, it is a complex problem because there are many microenvironments, and the microenvironments are very difficult, and it is difficult technically to capture the compounds because the aerosol is so volatile that sometimes you have under or overestimation, and it is a complex problem. But it has to be put in the context of general indoor pollution. The way it is complex, there are many studies, it's a challenging issue, but it should not be regarded as a toxic agent. Like like you could say that somebody that is cooking indoors with charcoal or environmental tobacco smoke that is heavily concentrated, these are singularities. These are real toxic singularities, but not vaping. Vaping is at the level of the indoor pollution that we are willing to tolerate. And then we have to protect ourselves because some of the studies on this topic, they warn about exposure in children. Say, no, this, okay, the particles, they evaporate, there's not so much fun, but children. Now, this is something that we have to challenge because if I am vacuum cleaning, it produces aerosols that are solid particles out of dust. But if I'm vacuum cleaning, I'm not going to take my child or a toddler and put it in the. Nobody will do that. If I am cooking, I'm not going to take a toddler and put it in the stove. So if I am vaping, I'm not going to go and vape into the face of the baby. So, but the governments understand that. The governments know that this is common practice, that people use common sense. Maybe some idiot will put the baby in the vacuum cleaner, but it is 1 in 10 millions. But when it is vaping, it seems that they claim this level of ultra precaution, which is not justified, right? So this is another issue, but it's not only technical, but there is a series of arguments that are based on the political issue of the political nature of the issue.
I had a question. How long the white
Before you guys.
Yeah. Used to make the measurements, how long the insulin particles going to stay in the...
The lifetime?
Yeah, the lifetime, yes.
So
This is
Microphone, please.
okay, it depends on the device, but if you are using a phone, then typical lifetimes are of the order of 11 seconds,
okay.
15 seconds. That's mean life, that's half-life. That doesn't mean it disappears. And if you compare with tobacco smoke, one puff is about 25 minutes half-life, right? It's no comparison.